Understand what are diamagnetic materials and why do they behave. So material which shows a weak opposition to any magnetic field. Basically, if I get a magnet near the material, one of the best example experiment out there is with the grapes. Not with grapes, with grapes. Alright, just a second. So you take a grape, tie it up, and get a magnet near it, it'll go back. So example listed is your copper, silver, so on and so forth. A basic explanation of why this happens. Again, a basic explanation. You have to keep that in mind. Don't write this in your exam. Diamagnetism arises due to the tendency of electron in atom to resist change in their angular momentum. They resist changes. In other words, angular inertia or angular laziness. That's the cause. But as per your books, this is what you have to write. Say we have two electrons. They are rotating in different direction. Okay, can do a better job. And this over here is, again, my device is sort of acting up. Battery is there, I don't know why. Okay, so this is a scenario. So in diamagnetic material, electrons often occur in pair, with one electron revolving clockwise and the other counterclockwise around the nuclei. So this is the scenario. Now when they are exposed to a magnetic field, a weird thing happens. That is, the one which is opposite to the magnetic field, that strength, the rotational stuff, the current loop increases, while here the current loop decreases. So here it increases, while here it decreases. That is the reason. Overall, the net effect is that it will be in the opposite direction of the magnetic field. It will be less because the difference between these two will kind of, it's subtraction basically. So it will reduce. So this pair typically results in a net magnetic moment of 0 for the atom in absence of any magnetic field, right? This is in absence. However, when an external magnetic field is applied, the electron's orbit motion can be affected. How does it get affected? Those electrons with the orbital magnitude moment aligned with the field tend to slow down, while with that of the opposite alignment speeds up. And so there is a small increase in magnetic moment in the opposite direction, and so it will oppose. Oh, my bad. This is not E, this is B. Okay, guys. So that's the funda. Oh yeah, still there's right up. This phenomena is a consequence of Lenz's law, which states that an induced current will oppose the change that causes it. This is something that we'll be seeing in detail. The net effect of this change is that the development of a small magnetic moment in the material that opposes the external field. This is why diamagnetic material are repelled by magnets. This entire thing is something that you guys have to write. Can't miss anything.